Hi, in today's tutorial we are going to detect objects using Detectron2. So this would be our test image, and after the prediction this would be our results. As you can see, all the objects are detected. So first of all the installation would be in my previous video tutorial, so this is the link. And this video is part of an object detection playlist, so you can cover more tutorials in this link. In the starting point, Detectron2 should be your home folder in the VS Code during the decoding. And let's start. First of all, let's create a fresh new Python file. Let's call it Detectron2 Simple Object Detection. Great. Now let's import some Python libraries. We will import a PyTorch, import Decathlon, and import a NumPy library. And of course we will use OpenCV. We will import some instances or let's say objects and functions from the Decathlon2. Model Zoo helped us to access pre-trained models from the object detection. Default predictor is a class used to make predictions with the Decathlon2 model. getCFG allows us to create and configure the Decathlon2 model. And to visual the results, this will help us to visual the predictions made by the model on our image. Also, MetaCatalog provides information about the datasets used in the trained model. So this would be our test image. Don't forget to change the direction of the slashes. And now we are ready to load the image using the OpenCV function IMRead. So the image variable contains our image. It's basically a NumPy array. And since it's a large image, let's reduce it by 30%. Once again, we will use an OpenCV function named resize. Basically, we are creating a new dimensions by reducing by 30%. Then we create a new variable, and this new variable contains our reduced image. Let's name it my new image. Now let's display our image using the ImShow function, and we will wait for a keystroke to close the image. Let's run it. Great. As you can see, we load our image. Everything seems fine. Let's continue to the next step. So now we will use the getCFG function from the Decathlon2 to create a new configuration object for our object detection model. This configuration object will hold all the settings of the model. Now we are looking for the relevant pre-trained model. Using this link, we are looking for object detections. As you can see, there are several types of weights. We will use this one, the R101. We don't have to download it. We can use some functions to download it automatically. So we will use the model_zoo get config file to specify a pre-trained model from the Decathlon model zoo. In this case, we are using the faster CNN R101 FPL. This model trained on the COCO dataset. Contains about 80 categories, 80 different categories. You can find more models in the Decathlon model zoo in this link. Next, we will merge this configuration file with our CFG keypoint object using the merge from file method. Then we set the score score fresh test parameter in the ROI head section of the configuration. This controls the minimum score required for the detection to be considered as a valid one. A higher value means the model will only predict objects with a higher confidence level. Then we use the get checkpoint URL to get the URL for the weights of the pre-trained model, and then we will set the model.weights parameter in the configuration to this URL, specifying the location for the model weights. As for device equals CPU, this line explicitly sets the device to be used running the model. So if you have a GPU, you can delete this line. If you have only a CPU, you might need this line to run the model. Next is a predictor. In this line, we are creating a default predictor object for Detectron2. This object allows us to make predictions on new images using the pre-trained model from the configuration above. The outputs. Here we are using the predicted object to make the prediction, and the results will be stored in the outputs. And those two lines, the print lines, are pieces of the information from the prediction results. The pred classes contains the prediction classes labels for each detected object. As you can see, these are the numbers. And the pred boxes contain the bounding boxes for each detected object. Now we would like to visualize the results. So we are creating a visualizer object. This provides the original image and the metadata about the dataset that was trained in the get CFG key points function, and we are scaling it by 1.2. Then we will use the draw instance predictions, and this method will visualize and draw the predicted bounding boxes and class labels on the image. This method takes the predicted instances and from the instances part in the output results, this take it as an input and convert it to a CPU memory if it's necessary. And then we are grabbing the image out of the out variable, and then once again we are using the imShow function to display the image with the predicted results. Now let's run it. We're expecting to see two images, the original one and with the predicted objects. Now you can see the results. You can also see that we have many predicted objects, like a person and handbag, trees, cars. You can also control those ones. I hope you enjoyed this tutorial. You are most welcome to subscribe. Bye bye.